Innovation and Collaboration Facilitator here at the Doolittle Institute, and this is Aisha Hyder, Doolittle Institute's Technology Transfer Program Manager, and it is our pleasure to welcome you all to the Technical Showcase event series. The Doolittle Institute is an Air Force Research Laboratory Innovation Institute and a Defense Works Innovation Hub, partnered with the Air Force Research Lab Munitions Directorate. We support the Munitions Directorate by working on licensing and commercializing its technologies in the private sector through technology transfer, by identifying and fostering new relationships through innovation and collaboration, and by developing today's students into tomorrow's STEM workforce. The goal of the Technical Showcase event series is to strengthen and broaden science and technology collaborations among academia, industry, and the Department of Defense through a monthly topic-focused interchange, thus providing opportunities to the government to share its research and technological needs with industry and academia, and for industry and academia to showcase their cutting-edge technologies and capabilities to government stakeholders. Today, I'm pleased to introduce our guest government collaborator for this month's topic, Multi-Domain Weapons Technologies, Part 2, Tailorable Trajectories. Dr. Anne Marie Petrock of the U.S. Army Combat Capabilities Development Command's Armaments Center. Dr. Petrock is the Senior Research Scientist for Warheads Technology and serves as a scientific and technical advisor on lethal mechanism technologies and is the principal proponent for the technology content of the Army's Warhead Science and Technology portfolio. She also serves as the lead for the Ordnance Key Technology area of the Office of the Under Secretary of Defense for Research and Engineering's Kinetic Weapons Community of Interest. Dr. Petrock, thank you for being with us today. I'm going to get your slides up for you. In just a moment. If you have any questions for Dr. Petrock, please use the chat function to pose them. These questions will be read after her presentation. Over to you, Dr. Petrock.
Thanks, Devin. I just want to do a sound check real quickly. Can you hear me okay?
Yes, we can.
That's great news. Well, thank you so much for that introduction, and I am so excited to be here to talk with everybody today for this showcase. As Devin mentioned, it's part 2 of a multi-domain weapons technologies showcase series, and this one will be focusing on tailorable trajectories. And I'm excited to hear from our industry partners, Minerva and Wave Engine, and I think we have some very exciting things lined up for today. So without any further ado, let's get started on my talk. If we can go, if I can't see if you have the charts up yet, Devin.
I do. I have your slides up, and when you're ready for me to transition to the next one, please let me know.
Okay, let's go to the next chart. Okay, so I just want to make sure that everyone's on the same page. Multi-domain operations means a lot of things to a lot of folks. In general, it comes across as military operations across all domains, and that includes maritime, land, air, cyberspace, and space. And it's enabled by integrated systems across those domains. The operations are often complex, dynamic, and require the integration of multiple operational nodes for success. So those are the kind of the key areas that people are looking at when they're talking about the multi-domain operations. And specifically, what we're looking to do is talk about how we get from point A to point B. So how are we getting from where we're starting and making that plan out to prosecuting the target. So if you can go to the next chart, please. What we find is that in reality, although that first chart looks very nice and cleanly separated, it's not nearly so much so easily distinctive when you're actually in it. And so really what we're looking at more is along the lines of what you're seeing in this graphic, which is all of those domains tend to overlap and kind of need to work together in order to be successful. If you are familiar with the National Defense Strategy, you'll notice that there are 3 core tenets that are guiding what we're trying to do. And so those are integrated deterrence, campaigning, and building enduring advantages. What we'll be focusing on today during this talk is the first two, which are the integrated deterrence and campaigning, and we will be building those enduring advantages through building the capabilities within those first two bullets. So under integrated deterrence, the concept there is that we can deter adversaries by ensuring overmatch across the domains. So we get there through synchronization of land and sea, air and space, and cyberspace technologies across the spectrum of conflict. And we utilize all of those capabilities in a singular symphony of activity. We then take that and we sequence it through a series of military activities in a campaign to shift the environment in favor of the United States. And all of that is made possible through the enduring advantages through modernization efforts and technology development made possible through academia, government, and industry collaboration. Okay, we can go to the next chart. So I mentioned that we're focusing on integrated deterrence and campaigning as our key enabling technologies for this specific brief. And so what we're looking to do is enable these long duration operations, and so that gets at some of the extended range and deep fires for real-time target discrimination and identification, tracking, aim point selection, and prosecution of targets. And so that's kind of the overarching methodology of how we're going to get there. And then specific technologies that we're looking for during this discussion are things that align with advanced fire control and propulsion coupling. So instead of just having a generic kind of propulsion charge that just says, hey, I know I have to burn at this rate, and it's a constant burn rate, how can we have a smarter propulsion and fire control coupling so that we can get into those deeper ranges? We will be leveraging heavily on advanced data collection and analytics, and that is going to require the use of sensing of the battlefield, sensing of the environment that is between the weapon system and the target, and integrating all of that to ensure that we can have a dynamic response. And so in order to get there, we're going to need dynamic propulsion technologies, which we'll talk about a little bit on the next chart. And then enabling that is things like novel initiation, energetics, and tailoring the trajectories on the fly by integrating those sensing modalities. Okay, next chart, please. So we'll focus on the first couple of those topics, the dynamic fire control and propulsion coupling, the advanced data analytics, and next-gen propulsion capabilities. So the two underpinning capabilities that we're looking for are on-the-fly discrimination and targeting, and that's going to require the use of sensor and effector information, looking toward more of the onboard processing capabilities as we're in flight, looking at the integration of forward sensor information with the fire control at the point of launch of the weapon. And so how we get there, we have some challenges ahead of us to get there. And so a lot of that is those sensor systems are power hungry. And so we are going to have to be leveraging different modalities for sensing. We're going to require two-way communications between the nodes as well as with the commanders. And that may be someone in an operating base in another country, on another continent, or it could be something as simple as someone who's right there kind of controlling what's happening. So we need to leverage those different sensing capabilities and be able to discriminate intelligently and prosecute those targets. A big challenge for us is latency. Trying to get the electronics to do real-time sensing and mapping, to make recommendations for courses of action, to prioritize targets, and to ensure that the communications are all happening without interruption and without a time delay is critical when you've got a dynamic battle space that you're engaging. And the more nodes that you have on the field, the more critical that timeliness of the communication is going to become. So making sure that we can address latency issues in communications as well as sensing and processing. And to get there, a lot of folks have relied heavily on AI and machine learning, computer vision types of strategies, but there are some challenges with the robustness of those methods as well. And so things like spoofing and miscalculations, weather, other countermeasures that exist make it a challenge to rely on things like AI and computer vision. And so looking for technologies that can outsmart the smart countermeasures that have been put in place. We also, as we're looking at getting into having further reach on these technologies, extended ranges and durations, the challenges we're going to find for survivability and robustness, what we need to do is be able to estimate initial conditions, but then be able to adapt given what the real battlefield intelligence is, and have some surety about that intelligence as it's being collected on in the battle space. We also need to worry about range. So typically we initiate a burn rate, which is constant. We started at launch and it continues, and we have nice models that predict how far we can go, and we're either going to put more propulsion behind something or propellant or a larger rocket motor. Rather than tailoring it for the conditions and for the terminal engagement that we're looking for. So looking to get at technologies that help us with range that aren't necessarily size dependent in order to get the duration we're looking for. That also then opens up the trade space for the payload capacities and the lethality advantages that we're looking for. We also need to consider terminal engagement. And so by the time we get to the target, we will need additional maneuver authority to close with the target. And we also will need additional power. So while we're powering all of those sensors and the onboard processing and the communication, we also then need to have the reserve power to be able to engage the target. So power becomes a real concern, as well as the propulsion system. The ability to adapt and modify the trajectory with dynamic targets and in a dynamic space where you've got multiple domain activities going on is challenging. And so we need to make sure that we have the ability to adapt to what we're doing with our trajectory through things like modular propelling chargers and rocket motors and other advanced technologies to be able to respond on the fly. Okay, if we go to the next chart. The other aspect that we're talking about under the key enabling technologies for integrated deterrence and campaigning includes novel initiation, energetics, and tailorable trajectories. So the graphic that you're seeing is from AIAA's review for propulsion and combustion. And it's a concept that they're studying for being able to use electrodes to change the effect of the burn rates and the mixes for the systems. And so there are different strategies that folks are looking at across the United States and internationally that are going after having the ability to tailor the propulsion system. And it's got to be a part of a bigger integrated weapon system. And so if we think about this in terms of tailoring the trajectory, the ignition being able to be adapted during the flight, as well as during terminal maneuvers and engagement, enable temporal and spatial alignment of lethal mechanisms to ensure we have the best effect on target. And so that gets back to some of the collaborative and distributed effects, excuse me, that folks have been exploring. essentially what we're looking to do is ensure that we have onboard analytics that can help determine muzzle velocities, at least at launch, but then be able to combine that with what the assets are telling them, what the assets are as they're aligned on the battlefield, and whether that's, you know, land or sea or air-based platforms that are forward, looking to make sure that we can achieve the desired outcomes by having a better integrated system. And then the extended range and duration of travel can be enabled by what I was talking about here in the, as represented in the graphic on the right, but there are multiple ways folks are going after that. But intelligent propulsion and burn rates, as well as looking at fire control logistics on board, rather than having it just having this minimal reach back kind of capability for the system. And so using that to be able to do target prioritization and prosecution. So the things that are going to get us to this, the point we need to be from a national defense strategy perspective, the component technologies are going to be critical, and as is the system integration. And a lot of emphasis has been put on the terminal engagement aspect of it in terms of the integration of the fire control with the intelligent propulsion systems. I think that there's a lot of opportunity here for growth in that area. And I'm excited to hear about what folks are working on. I think that integration is the missing piece that we've got for transforming the landscape. I think that a lot of folks have just kind of jumped down the path of using these buzzword type of technologies and saying it's AI or ML, and I would suggest that that's not the cure-all. I think that we need to pay attention to what's happening because people have found simple ways to counteract some of our most advanced technologies. So as we're doing all of this advanced development, we need to keep an eye on the simple countermeasures of things like denial, deception, and camouflage. And we need to pay attention to that while we're designing these technologies and we're integrating them so that we don't have a blind spot even with all of this advanced technology. And we've got to make sure that the system is robust to loss of nodes. There's a lot of really advanced countermeasures that are coming out. So how do we make sure that this thing, that our system can still get where it needs to go, despite loss of communications, loss of individual nodes, where you, upon launching the system, you think you have 5 nodes ready to go after one target. And that's what your initial plan was. Now, how do you adapt for that dynamically when you're down 2 nodes? So the system's got to be robust to be able to account for that from a fire control perspective, from a lethality perspective, and it's got to be able to be modular and interoperable. I mean, when we talk about multi-domain operations, the biggest challenge is getting these things to communicate across all of those domains and platforms. So interoperability, and they also need to be able to stand alone. So the onboard processing then becomes more important. And so those are the main points I wanted to give. I wanted to leave some time for some conversation before we move into our next 2 presentations. So with that, I guess I'll close and I'll hand it back over to you, Devin.
Thank you so much, Dr. Petrock. Just 1 minute so I can get your presentation off my screen and we will go to questions. All right, do we have any questions in the chat, or does anybody have anything that they would like to unmute and ask Dr. Petrock? We do not have any questions for her. I'd like to let
I
you
really
know.
appreciate the presentation. Can I ask a question?
Absolutely, go ahead.
Can you hear me?
Yes.
Yes, go ahead.
Nice. I really appreciate the question. Tom Humans from Roman Aerospace. Very great to see all this information. I was wondering, is there a focus on avoiding intentionally cameras for pieces of this to keep the munitions entirely electronically silent? Is that a focus area? What are the thoughts on that?
So I missed the very first part of your question. Your audio cut out. Can you repeat the question, please?
Yeah, I was wondering if some of these, if there's a focus on avoiding any sensors that emit any radar or LiDAR and just using cameras and visual systems and intentionally avoiding communication to keep the system electronically silent and dark.
We are always interested in pursuing technologies that help us with against countermeasures, so countermeasures. So things like optical tracking and navigation is of great interest.
All right, thank you. We have another question in the chat. It says, are you interested in novel GPS-denied navigation capabilities developed by US SOCOM?
I'm sorry, I think my internet also cut out there, but yeah, visual navigation systems to avoid any detectable sensors and avoiding communications to keep the system electronically silent, if that was a focus and the goal.
Absolutely. So that gets right back to the robustness aspect that I was talking about. So we need to be able to get into contested areas, and we also would like to be able to survive. We need to be able to survive countermeasures, and that is exactly a strategy that has proven successful getting there. So yes, there's a lot of interest in that.
Interesting. Nice. Thank you.
Thank you. Was that your question in the?
No, I think that was someone else in the chat. It says, are you interested in novel GPS denied navigation capabilities developed by US SOCOM?
I think we're open to things that are developed by any U.S. partners. So yes, if SOCOM's got some technologies that are already advanced, we would love to hear about that. Probably not in this forum, but it would be great. GPS denied, like I said, contested areas is always a challenge. And so making sure that we're invisible in those environments is really, really going to be critical to our success.
And then the follow-on says, how would we contact you about GPS denied tech? Michael, you can actually email us at doolittleinstitute.org, or sorry, at technicalshowcase@doolittleinstitute.org, and we can share contact information and schedule any follow-on with Dr. Petrock for you. All right, any other questions in the chat, or anyone like to unmute and ask their questions? All right, if not, again, I would like to thank you for your presentation today, Dr. Petrock. Everyone is welcome to contact the Doolittle Institute at technicalshowcase@doolittleinstitute.org if they would like to further engage with Dr. Petrock. Also, if you're interested in collaborating with the Air Force Research Lab Munitions Directorate through the Air Delivered Effects Broad Agency announcement to develop munitions and other related technologies, you should contact us to schedule a meeting. We are looking for partnerships with industry and academia in areas such as autonomous target recognition, sensors, navigation, and cyber resiliency. And we also have licensing opportunities available. To stay current on our upcoming technical showcases, please join our ecosystem at doolittleinstitute.org and follow the Doolittle Institute on social media. There will be many future opportunities for industry and academia to engage and submit applications to highlight their cutting edge technologies and capabilities and learn more about what the Munitions Directorate and other featured DoD collaborators are working on. Additionally, Dr. Petrock's presentation from today will be posted on our website if you'd like to visit it or to view it in the future. And we will also post the recording of today's event there too. If there are no other questions, we'd like to thank you all for attending today and say have a great afternoon. We'll see you next time.